We are building these 21st century skills K through 12 each year, building on the other year. So we decided to take just one discipline, math, and in subsequent meetings we will take other disciplines and do the same thing. And we're going to have an elementary presentation, a middle school presentation, and a high school presentation. Each one of those presentations will show you how, at the different levels, the 21st century skills are built and developed. At the end of the presentations from the teachers would be happy to take any questions. I would be happy to take any questions on the lens in general that you may have had as you were looking at it over the weekend. One other thing, I just want to give you a little preview of what to look for. There's so much on the lens that, you know how in speech classes years ago, how speech teachers used to say you should make a speech. Tell the audience what you're going to tell them, then tell them what you've told them. So in order to give you a little preview, all three groups of teachers are going to be focusing on the critical thinking capacities. So if you're looking at your lens, by the time we get to the high school, you will see that all of those capacities under critical thinking, accessing, analyzing, synthesizing, evaluating, as we move up through the high school, you will see those capacities will have been touched by the lessons. Then if you look at the creative capacities, and you look at rows 3 and 4, risk-taking and tolerating ambiguity, and agility and adaptability, those tend to be not so much skills, but those are the attitudes and dispositions that all research groups agree are absolutely necessary to be successful in the 21st century. And there are a number of attitudes and dispositions, including resilience. You know, something goes wrong with your project, you're faced with a snafu, how do you handle it? To be agile, to be adaptive, to persevere, to be resilient. That whole complex of attitudes you're going to see addressed by the teachers. And in particular, you will hear our first teacher, when she talks about elementary school, she's going to share a parable with you of the butterfly, which is absolutely relevant to K through 12. The communication capacities, not so much addressed in these particular presentations, except you will hear from the high school unit when they got advice using the lens about how they could add to their capacities. They got advice around communication. And then finally, if you look at the global thinking capacities, you will see all of the teachers talking about real-world problem solving. So there is no unit that's going to address all capacities on the lens. What we would hope that by the end of a school year, there would have been units across the year that have developed those different capacities. But obviously there's so much going on here, you wouldn't think that one unit would do it all. All right, so ladies, if you would like to come forward.
Chairs?
We should have 5 chairs up there.
One here.
5 chairs.
Okay, so we have from the elementary school, Joanne Fasciola, who is a math specialist. We have from middle school, Tanya Kaplan, who is a 7th grade math teacher. And from the high school, we have 3 high school teachers, Jennifer Judas, Trudy Denton, and Sarah White. So Joanne is going to start us off.
Maybe towards you.
I don't know. Slide the button up.
I did do that.
No, it's
Is
on,
it
it's
working now?
on.
Okay. All right. Well, good evening. I'm Jo Fasciolo. Thank you for having me. As Liz said, I was asked to come and speak to you about making thinking visible using model drawing, actually, which is a strategy from our Singapore math program. And I wanted to start off, as mentioned too, with a little brief story in the spirit of spring and 2025 about a butterfly. And we all know that a butterfly doesn't start off as a butterfly. In fact, we also all know that it goes through many phases to become that butterfly. Starting off as an egg, it hatches into a caterpillar, and the caterpillar eats and grows and gets nice and fat. And when the time is right, it weaves itself into a chrysalis or a cocoon. And while in that chrysalis or cocoon, it changes into a butterfly. And amazingly, the butterfly actually takes several hours to break out of that cocoon. It starts off with a little hole, and it struggles and it works and it struggles and it works until finally it's ready to push its way out and it's free to fly. Now, what I didn't know, and perhaps some of you don't know, is that if you try to help that butterfly by cutting it free, it will come out easily, but it will never fly. Your help will actually destroy the butterfly. It will fall to the ground, swollen, and eventually, unfortunately, die. Without the struggle, important enzymes that give the butterfly its strength won't be activated. So, as is the case so often with nature's design, I think we can learn a lesson from that butterfly. And that lesson being to help nurture a proficient global 2025 student, we need to provide students with the challenges that they need to struggle through things. But we also, like the butterfly, need to provide them with tools like that enzyme so that our students can gain the strength and learn how to struggle independently. And our Making Thinking Visible through Singapore Math and model drawing is a strategy that helps with that, developing that strategy and the rigor in children that we're looking for. So now imagine that you're a 5th grade student and you are given this problem. You'll each get one. Just pass them around, please. Okay, I don't know if we can all see that very clearly given the lighting. I'll wait till you get your own papers.
So it's coming around.
Joanne, you might want to mention that you're using a document camera.
Yeah, this is...
Why don't you talk about that a little bit?
Well, it's a document camera that is just projecting from a piece of paper. I'm going to write directly on the paper here, and you'll be able to see directly what I'm doing as I'm writing. And I do believe you approved the purchase of several of these for the school, so thank you for that. It makes us help make our thinking visible. Okay, so now that we all have the problem, and like many students, you are right at reading it and you want to try to solve it right away, we're going to ask you to bear with me because I'm going to walk you through the process of model drawing. Model drawing, as I mentioned, is a strategy that's used in our Singapore Math program, and basically there are 3 phases. We're going to start off in a text phase, which you have in front of you, which is the problem. Can you see that okay? Yeah? Okay. And we're going to work through... That actually removes my light, so yeah. It'll come back. Oh, give it a second. My hand's here. Okay. So that's okay. So we'll move... basically, the 3 phases are moving from the text phase. And again, keep in mind we want to make our thinking visible, and we're going to move into a model phase. And then we want to move into a more abstract text phase, proof phase, okay, where you're actually using numbers and symbols. And I want to just state that, simply put, math uses numbers and symbols to represent ideas. So we want to be able to help children access these ideas and represent them through numbers and symbols. And what we often do as teachers is we start at this text phase where we've got a bunch of information in our word problems, and we move straight to the abstract phase, and we lose an opportunity to help them develop the concepts and be able to actually help themselves solve problems. So I'm going to walk through this to help see how it all works. The first phase, as I said, is the text phase. We're going to start by reading the problem through once. Mary baked some cookies. A quarter of these cookies were chocolate chip cookies. 2/5 of the remaining were sugar cookies, and the rest were peanut butter cookies. When she was done, there were 18 peanut butter cookies. How many cookies did Mary bake altogether? So the purpose of that first run through, so I'm sure some of you have the answer already, but the purpose of that whole first read is to get the big picture. And now that we've got that big picture, we're going to walk in and take out some of the detail. So I'm going to do what I would do with students, but I'm going to abbreviate it, go a little faster. We're going to read and chunk and put little stop signs in. So Mary baked some cookies. Stop. And every time I stop, it's where there's something important. So if you want to chime in and tell me when to stop, you can. That's what the students would do, but you don't have to. 1/4 of the cookies she baked were chocolate chip cookies. Stop, thank you. 2/5 of the remaining were sugar cookies. Stop. Now, it's important to note that you don't just stop because there's a period. There's no stop there. The stop is associated with something important in the text. And the rest were peanut butter cookies. Stop. When she was done, there were 18 peanut butter cookies. Stop. How many cookies did Mary bake altogether? Stop. Now, the kids would learn how to walk through this phase, independently. But we're not quite done with the text. We want to focus in on what is the problem actually asking, and we're going to make an answer statement before we have an answer, so we don't lose sight of that. So I'm going to look at the question that says, how many cookies did Mary bake altogether, and just flip that around and write that Mary baked, I'll make sure you can see it up here. Mary, can we see down there? Baked blank cookies. All right, so I've completed my text phase. I've got the big picture of my text. I've backed into my text. I've interacted with my text, much as you're doing in your language arts programs. And now I'm going to take each chunk of that, and I'm going to truly make my thinking visible. And I'm going to bridge the kind of abstract ideas that are in this to my numbers and my symbols. So typically what I will do with kids is I'll say, we need a place to start. So on your mark, get set, go. And I'll make a start line. And we'll back into the text. And everything in the text needs to be represented in the model. So Mary baked some cookies. Who and what is our problem about? It's about Mary's cookies. And obviously the kids would be doing some of the responding and then bridge themselves to do this independently. So now I know this is about Mary's cookies. And the unique thing about model drawing is it uses bars to represent what you're talking about. So I'm going to create a bar to represent my whole. All right, that bar now represents Mary's cookies. 1/4 of the cookies she baked were chocolate chip cookies. That's my next stop point. Now, because I understand fractions, I recognize that the numbers and symbols used in fractions, my denominator of 4 is going to tell me to break my whole into 4 units. So I'm going to go ahead and break my whole into those 4 units. And I also recognize that the representation of a fraction shows me that the numerator, or that 1, is going to tell me that one of these units is devoted to her chocolate chip cookies. So I'm going to label that. And you can see the thinking is coming visible. The words are now represented in the model. 2/5 of the remaining were sugar cookies. That's my next stop point. So I know that I have this section of my whole is now the remaining, and I'm going to pull that down because I'm dealing with a new unit. My unit now is no longer fourths. My unit now is fifths. So if I were teaching a group of 5th graders, I would say, well, what makes sense to do next? And what would make sense is to break this whole, my new whole, into 5 units. So I'm going to go ahead and do that. And does anybody dare to tell me what would come next? What makes sense? If I have 2/5 of the remaining cookies were sugar cookies, and I have broken it into 5 units, and I'm trying to make my thinking visible. Go ahead, help me out. See, I knew you'd help me out because I taught your children. All right. So I know that I need to devote 2 of those units to and identify them as sugar cookies. Okay. So now I know as I'm chunking, my thinking is becoming visible, and I know that the rest were peanut butter cookies. So I'm going to identify those as peanut butter, and peanut butter. So notice how I'm checking off each a stopping point. So I'm making my thinking visible. I'm keeping track of my own thinking. And moving along, when she was done, there were 18 peanut butter cookies. So if these 3 units represent my 18, I can pull that down and identify that as being 18. Finally, I want to know where my question lies. My question is, how many did she bake altogether? So I'm going to put a question mark there. And what I've just done is I've taken my text, I've identified the important detail or the clues that are in my text, and I've represented that in a model. And my model, and it's important to note right here, is not only going to make my thinking visible to somebody who's looking at my work, but it's going to make my own thinking visible to myself and give me the aha moment I need to actually start working backward through my problem. I'm now going to use what I know to figure out what I don't know. And here's where I'm going to start using numbers and symbols. And this is a very pre-algebra, a good setup for algebra kids moving forward. So I'm going to take this section now and I'm going to say, well, if I know I have 3 units that have a value of 18, by division, I now know that 1 unit has a value of 6. And notice the use now of abstract numbers and symbols to represent ideas. So now if each one of these values has a value of 6, if 1 unit has a value of 6, then because I'm dealing in fractions, all my units are the same size, all my units have a value of 6. So 5 units is now going to be the same as 5 times 6, which gives me a value of 30. And so I now know that this section is worth 30. So what would make sense to do next? Anybody? If I know this section is worth 30 and it's the section I pulled down, this section must also be worth 30. So if this section is worth 30 and I'm dealing with a separate set of different unit size, okay, my 3 units is worth 30. So again, through division, 30 divided by 3 equals 10. 1 unit has a value of 10. And so if 1 unit has a value of 10, then 4 units through multiplication would be 4 times 10, which has a value of 40. And so I can come to my conclusion that Mary baked 40 cookies. And I took the ideas that were represented in my text and I moved them through a model that made my thinking visible and actually unfolded my own thinking and helped me use what I know to figure out what I don't know to back into the fact that she made 40 cookies. And I can represent the ideas that are in the model and all my unknowns in the model through the numbers and symbols, which eventually is where kids will be as they move forward into algebra and such. So in closing, our goal is to help students develop skillful math and problem-solving dexterity. And we want our 2025 math students to have conceptual reasoning. And here the concepts are made visible through this procedure of model drawing. We want them to have procedural fluency. And procedural fluency doesn't come without truly understanding the concept. So again, this lends itself to move towards procedural fluency. We want them to have strategic competence. And so have that ability to independently struggle and without walking them through it. So knowing how to use models to develop strategies to solve problems doesn't stop with a fraction problem. You can use models to solve all kinds of problems. So it's a strategy. It's like the enzyme that gives them the strength to independently follow through on something. We want them to have adaptive reasoning. Okay, use what you know to figure out what you don't know. Adjust to things. And we also want them to have productive dispositions. So all of these things combined, obviously we want them to apply these capabilities to a variety of complex situations and be able to explain the reasoning. And so this model draw helps to explain reasoning and to make their thinking visible. So explicitly teaching students the skill of visualizing their way through math concepts will not only help them gain the confidence they need, but will also help them develop the strength and the resilience to struggle independently, like the butterfly. And we know these skills are necessary to be successful as a global student and thinker. And I've used this very successfully with students, and it really opens up a lot of aha moments for people. It's not so scary when you can just work your way through it this way. And eventually, this kind of thinking is something that takes place in your head, and you don't need to write it down. Kids often very quickly move on to visualizing the quarter, pulling that down, breaking it into fifths, and recognizing how to get to a solution to a problem like this simply by doing it in their head by the power of visualization, which we often do in language arts, but now pulling it into the math domain has a lot of power. So thank you.
First, if Mary's here, I'd love a peanut butter cookie. So,
I should have baked cookies. I was going to release a butterfly, but
is there a visible aspect to the simple division and multiplication you did? Because I was sort of
yes, that's a great question. This is a fraction example. You do model drawing for any computation, whole number or decimal or fraction, multiplication, addition, subtraction, division. There are model draws that represent all of those ideas. This was a more complicated fifth grade problem, but when you're starting off in first grade, that model is two bars that are joining two things together. When you move into multiplication, you're repeating units, and they're seeing the repetition of those units and looking at multiplication through repeated addition. When you're working with division, you're taking a unit and you're breaking it into, as we did here, into equal parts to represent, well, what makes sense? If I know my whole is 18 and I have 3 parts, what makes sense? And you physically, another aspect of Singapore math is to use manipulatives. You would physically have 3 plates and 18 chips, and you deal them out until you realize that 6 went into each. So yes, there is.
Thank you. You've helped me with my 5th grader, Jax.
Good.
I appreciate it. But a question for you. What would this lesson have looked like 2 to 3 years ago?
Well, that's a great question. Well, I think it probably would have been reserved for students who are of a more natural disposition towards math and a higher ability level. And I think it would have taken a feel of, using your traditional fraction concepts and algebraic approaches. And again, the beautiful thing about this is that it bridges the idea of this with the abstract or the proof or the numbers. So yeah, it would have gone the traditional. I mean, I can't say for sure what everybody would do. I'm sure some people were pulling out manipulatives and doing it through concept. But I don't even think this level of problem would have been in a 5th grade classroom, to be honest with you.
Okay, shall we move to 7th grade?
Is the math going to be harder?
A little.
Okay.
A little. Wait till we get to high school.
This is where the train leaves Chicago and the train leaves New York at the same time.
Question is, do you know what the password is?
Hi, I'm Tanya Kaplan. I am currently working at Coleytown Middle School in the 7th grade, and I am going to be talking today about using non-routine problems and making thinking visible in our classrooms. Again, we're trying to build these critical thinking skills and cooperation skills and really bring the 21st century into the classroom. What a non-routine problem looks like is something like this. This is a question I used in my pre-algebra class in the beginning of the year to teach the distributive property. Now, at first glance, a student might be overwhelmed by the fact that this is not typically what they've seen when using the distributed properly, as well as they're not getting any help from the teacher, which might be an overwhelming fact to them. Like Joanna is saying, we want the kids to struggle a little bit, and we really want them to learn those independent skills. So this really brings those questions about of what do I know from this diagram? What do I need to know? What am I being asked to solve, and how am I going to get there? This is different than the normal way we would be teaching the distributive property, where we just give them a problem like this, and through repetition, we have them do it over and over again until they've memorized the property and how to use it when solving for the variable x. Some of the benefits that we have seen through these types of non-routine problems are the improvement in their group collaboration skills. In the problems, they're allowed to work with whoever they want. They're allowed to walk around the classroom. They're allowed to ask questions to their peers. I do lead them in the right direction. However, I will never tell them you are right. I just encourage them to keep working. You're on the right track, and let's see what we can come up with. They also make the real world connections from these types of problems, whereas in other schools, they sometimes don't even use numbers and they just have to use their critical thinking skills. With these non-routine problems, they also get to use multiple perspectives where they're approaching the problem from many various different ways, and they have to learn the tolerance of ambiguity, where there might be several ways to solve the problem and come up with the correct answer. And lastly, they are modeling higher order thinking skills and asking questions, such as when we go over these questions, we typically ask the students, what do you know? How do you know that? What justifies that you said that? Can you prove it to me? What are the implications of what you've just said? And finally, is there anything else you should know or think you should know to be able to help you to solve this? So it really gives us an idea of how are they explaining themselves? Do they really know the theorems and the reasoning behind what they're saying, or are they just saying it because they think it looks that way? So it gives us a justification also as what do the students really know? Some examples of some student work that I've collected have ranged from all different levels, such as the lower student the first time around might not be able to get too much on the paper. As you see, he was struggling a little bit here on making some connections of finding what do I really need to know here. Whereas a higher learner might be able to get a little bit more down, make some more connections, and really start to work out what the question is asking them. Now, like we were saying, we want them to struggle because the second time around, this same lower student was able to get a little bit more down. He was really refining those problem solving and critical thinking skills of allowing himself to, maybe he's not going about it the right way, but he's taking a chance. He's allowing himself to work with other people and ask questions, and it really promotes those critical learning skills of them making the connections and the concepts to pass knowledge. Now, another part of these non-routine problems are the student reflections, which are based off of the 4 C's, which comes directly from the Making Thinkable book by Ralph Richart. We did adapt these questions from the book because we felt they really collaborate well with what we're trying to do. The concepts part being, what did you need to know to solve this problem and have to use in order to solve? What connections of past concepts did you have to make in order to solve this problem? What challenges did you face and what did you need to get around them? What did you do when you were faced with a challenge? And lastly, how does working on this question like this change your way of thinking? These provide good discussion topics for us, as well as it gives us a feeling of how the students are reacting to them. Are these types of problems helping them? And some reactions that I've got is, it was really frustrating to me. This problem was really frustrating. But then once I got over my roadblock, it was an aha moment. And as a teacher, it's a great feeling to have to see that they are frustrated. However, once their connections are brought to light or they get past their hurdles, they are having those aha moments and they are making progress in their critical thinking skills. The result of these non-routine problems of making connections to the capacities in the critical lens, it's that students are synthesizing and making applications where they make connections among key information, ideas, and concepts and apply to other contexts. Their risk-taking and tolerating ambiguity skills have improved where they're seeing that you can explore new possibilities for approaching an ill-defined problem, potentially with multiple solutions and through different means. And lastly, is promoting those collaboration skills that they're able to ask each other for help and they're not ashamed if they get the answer wrong. And it's really nice to see them working together in this capacity. Overall, I have really enjoyed involving these types of problems in my learning. I think the students get a lot out of it and they look forward to the days when they can do challenge problems. And I would like to continue and see where it's going to take us into the 21st century.
Can I ask a quick
Jane,
question?
Sure.
You talked a decent amount about how this is helping some of the kids that are frustrated in trying to solve the problem. Can you comment on the kids who go immediately to solving the problem, but maybe don't like to explain their thought process so much, and how this might be helping them?
Sure. Typically, when I'm going over the question, if somebody likes to volunteer information, I always ask them, well, why? And how do you know that? How can you prove that? If you were going to explain that to someone else, what would you say? Because I don't really know what you're talking about, and I like to play the dumb card of, well, I don't know what you're talking about. I've never seen this before. So I have them explain it in that sense where they're able to articulate what they're trying to put down on paper as opposed to just going about it and solving. And I do encourage the students that want to work along to maybe help a struggling student to promote their explanation skills and their collaboration in both aspects.
We ready to move to the high school?
Thanks, Tanya.
Oh no, now we have AP math.
As long as we're not on the spot to answer, we're good.
Advanced calculus.
Went through it once, and that was enough for a lifetime.
Second derivative always.
Did you do a lot of right?
Hello, I'm Jennifer, and Trudy and Sarah and I hope to give you a glimpse of how our school goal of greater conceptual understanding on the part of our students is being encouraged and fostered. Teachers were encouraged to write their PDUP goals focusing on the 21st century skills. We wanted to create a lesson that would give our students the opportunity to interpret data that is relevant and meaningful to them. And given that data, we wanted our students to decipher what information was important to the problem solving process, create mathematical models allowing them to make predictions, and then effectively communicate their findings, while all along practicing traditional mathematics skills that will strengthen their foundation within the context of real-world problem solving. Ultimately, upon the completion of the lesson, we wanted our students to achieve a deeper understanding of the quadratic function. We designed a lesson that would allow students to evaluate the profit potential of a phone to compete with the Apple iPhone. In order for students to solve this multifaceted problem, we felt it was necessary to familiarize them with the smartphone market. We did this by looking at Apple's 2011 10K. Students looked at the net sales and the percent change. They had discussions around how to interpret the data, product comparisons, and relevant market factors. The classroom discussions created an understanding to then look at our simulated company, Sharpphone Incorporated. We created the following classroom scenario, and the students were presented with the following. Your marketing and research department has generated the following demand data for your product, the Sharp Phone. The data is based on extensive market research. The marketing department believes the projected sales prices are justified because the Sharp Phone features numerous interactive features, upgraded camera software, and a much larger viewing screen. And below that, you can see the simulated data, which was also provided to the students. We had discussions in small groups and as an entire class pertaining to the given information. The students created both linear and quadratic models, which I will show you on the next slide, and then they interpreted that information. They made predictions in context of the problem while still practicing valuable foundation skills taught earlier in the unit. Using linear regression, you can see up in the upper left-hand corner, the students created a model relating the sale price and demand, and this is something that they generated. They contextually interpreted the slope and y-intercept values, and we also discussed concerns about scaling and extrapolation. Next, the students developed a quadratic profit model, which you can see in the lower right. They began the process with words, profit equals revenue minus expenses, and there were a lot of discussions that went around this and as we developed this, and you know, a number of students participated and had ideas. You know, some were correct, some were incorrect, but this was our final result. They used previous findings to substitute mathematical expressions, and ultimately they created the quadratic model to find the optimal sales price to maximize profit. The students interpreted the vertex, which you can see marked there on the graph, the x-intercepts and other characteristics of the graph, ultimately determining that the sale price of $370 per phone would result in profits over $15 million. The teachers, a few of us taught this particular lesson, and we were really pleased with how it went. We were excited about the student feedback and their ability to connect to the topic and really explore it and want to understand the market behind it.
We hope the math got harder. Now, coincidentally and fortunately, right about the time that we were developing this lesson and teaching this lesson, the lens was being developed with Teachers College. And so the two events kind of happening together gave us the opportunity to use the lens to get feedback on this lesson that we thought was a pretty good lesson, but really wanted some direction on how to make it better. So here we go. Fast forward to the February 27th PD Day, and we kind of decided we wanted two goals out of that workshop, and those goals were to introduce the lens, as you see up here, to the middle school and high school math teachers, and to actually use the lens, get experience using the lens to get feedback on the lesson that Jen just presented. We went about that process in much the same way that the task force did. We utilized the same approach. Small groups focusing on individual domains and the building capacities, and then reporting back to a large group. So what we did was we took over 40 middle school and high school teachers along with a handful of special education colleagues and split them up into 5 groups, and each one was given a domain or capacity across the top. And one group we had 2 groups focusing on the critical thinking capacity. There are 4 members of the 2025 task force in the math departments, and they explained the lens to the teachers. And then each group was given a sheet that looked a whole lot like this with the capacities and the underlying skills, and as you can see, the progression of the skills that go towards what a global student ought to be able to achieve. And they split up, they talked amongst themselves, they looked at the lesson in the context of their particular capacity. The 4 members of the task force kind of, along with Frank, kind of circulated around and facilitated those small group discussions. And at the end of the discussion, we came back and the small group shared their observations both about the lesson and about utilizing the lens, what they liked and what they didn't like. And Sarah's going to tell you about what we found out.
Okay. Here we go. First of all, we had the teachers give us some positive feedback about what they liked about the lesson per se. Like we said, we thought it was a pretty good lesson. We'd spent a lot of time putting into the lesson, but we wanted to see what they said. One thing that they really liked were the thought-provoking questions. They felt that we asked students to think critically throughout the lesson, and they thought that that was really important and something we've heard, I think, everybody talk about tonight is thinking critically, and has been a huge goal of ours. So they were happy to see that. Second of all, they were happy to see that we used a familiar product by using the Apple iPhone. I mean, half our kids have iPhones at this point. The ones who don't, their parents do, or their friends do, or they want one. And not just that, but we looked at all the Apple data. So when we looked at the actual data and we gave them the sheet that came from the annual report, the kids could analyze, and kind of gets into the next bullet point, the real world data, and to talk about the iPad versus the iPod versus the iPhone, and look at all the statistics. And it came up with great discussion points and things that we didn't necessarily anticipate, but things like, why are the numbers in parentheses, and how is it that if the report came out in September 2011, it can have data for the entire 2011. So it had lots of good real world applications that connected. And I think that was one of the things that the teachers appreciated the most, was that we took skills. We always say we want to use skills as much as possible in a real world context. And a lot of times that's, well, you take a word problem out of a textbook, and well, the word problem might be really old. It might have nothing to do with what the kids really care about. But here we were using being able to put their skills to use in a very real world context that they cared about. The next goal we had with the teachers was asking them to look at the lesson through the lens. As Trudy and Jen mentioned, the lens wasn't really part of the whole game when the lesson was made up. So we asked them to look at it through the lens and talk to us about how we could improve upon this lesson after thinking about the lens. One of the things they suggested, the way the lesson was taught, it was mostly a whole group instruction as well as some individualized learning. And they suggested that in the future we could have students work together and to collaborate so that we could work towards that collaboration skill. In addition, they suggested that we encourage students to practice agility and adaptability. That came straight off of the lens, in case you're wondering where the wording came from. And that one of the suggestions they had was throw a constraint at them. Say, okay, the iPhone parts are manufactured in China. Let's say there's a massive earthquake in China and all of a sudden the factories can't produce things anymore and there are no more workers or a lot less workers to work or whatever. What's that gonna mean? How is that gonna affect the bottom line? How is that gonna change the profit equation? Basically what happens and what's gonna happen if that happens? The third bullet point, I think it's been a hot topic right now in the news, is the working conditions, especially for Apple, who's been so secretive about where they produce their phones and the parts and where that comes from. And one of the groups suggested towards the global thinking capacity would be to combine having students think about Apple, for example, and go home and do research about the working conditions in China and other places, and to say, well, let's say, is that a good thing to have workers in China, or should we move them to America? What would that mean if we now have to pay them a minimum of $9 an hour instead of paying them $1 a day or whatever that is, and how we could connect with that. And finally, this fourth and final suggestion they had was to communicate solutions effectively and have students do that by perhaps writing a letter to the CEO or having students make a presentation to board of directors and maybe pull in some of those global awareness humanitarian pieces and pull in some of the constraints and what would happen if there was a crisis and how would that change things. So I think it was really rewarding for all of us who've taught the lesson, who worked on the lesson, and also just a great introduction to the lens, how it can be used, how we can now use it in the future. And I think a lot of us are very excited to improve upon this lesson, but also to use the lens this summer in our summer work to really think about how we can make our lessons even deeper and more exciting for students and more relevant in making them global thinkers of the 21st century.
Thank you very much. In about 40 minutes, we have made a journey from elementary to high school in terms of teaching and learning math. And I think you can see how we are building on the capacities year after year, using the same language, making thinking visible, critical thinking, collaboration, perseverance, and so on. So we would be happy to entertain any questions or comments.
Mike. I apologize if I missed this, but what class was that taught in? What level, what grade?
Algebra 2. And just because of the way the curriculum works, we've only done it at the honors level so far, and the A level and B level are going to do it towards the end of the year, just because in honors we tend to move faster. But it is something that we would like to be a common experience throughout the levels. It's not a certain level thing.
Jim?
Understandably, all tonight's examples were about mathematics. What has been our experience in other curriculum, science, language arts, et cetera? Where are we with
In exactly the same place, and we hope in other presentations to you to take language arts, to take science, to take social studies. We thought this would be meaningful because one of our big pushes for Westport 2025 is to have it really be K-12, not just at one level. So we thought it would be interesting for you to see how one subject builds from level to level, and we'll be showing you other ones.
Great. Thank you.
Jen?
The same question for the three of you that I asked before. What would this what would this have looked like from a lesson standpoint on the subject 2 years ago, 3 years ago?
I think I'm, to be honest, pretty dry. In the past, it's been like, well, I think what's interesting, I also teach personal finance, and I've learned that kids don't know nearly as much about money as we may think they do. I think we've had conversations about that with the finance. It's kind of scary sometimes. But we have to start from even just profit versus revenue and how those are two different things. So we sort of start with that, and then we basically have developed the fact, well, where does revenue come from? And they get the concept that if you sell 10 glasses of lemonade and you're selling them for $1 a piece, that your revenue is going to be $10. And we sort of start with, I mean, at least that's personally how I've always done it, and sort of work backwards to say revenue is price per item times number of items. And then we've had the revenue problems we've done in the past have been kind of dry, and I think that's where the initiative has come to. This is a concept that could be interesting. If we spend some time and really delve into it, we can make something really interesting and way more depth with it. Because in the past, it's just been sort of the idea of if you bump up the price by $1, you're going to lose 1,000 subscribers. What's the optimal price that you should charge to maximize revenue? It's been very straightforward. So this has given it a lot more interest. And the kids really got into it too.
Sure.
Yeah, they had fun.
Sure.
Mark?
As I've heard some of these things, I've been trying to wrestle. How is it different than what it was a couple of years ago? And we really just started to have a lot of this discussion. We had some curriculum reviews over the past number of years, and they've obviously changed and enhanced the programs. But as I take a bigger, longer-term picture, going back to when I was learning these things, back when rocks were young and dirt was new, that there were a lot of things that I'm seeing happening are that you're making it far more relevant to the kids that they're learning it. For me, it was almost not quite memorization. Doing the math was, here's the problem, and here's how you come up with the formula, and here's how you solve it. Whereas now the subjects are subjects that they can relate to. An iPhone, for example, right? They know what that is. They know what Apple is. They even have it introducing the manipulatives at a younger age to bring reality, and concrete examples in a lot of different areas. And I think that's to me that's where a lot of this has happened, as well as in some of the classes that we've had where you have what you're doing in language arts relates to what you're doing in social studies, which relates to what you're doing in mathematics, and tying those things together so it's not these what we tend to call in industry silos of information. But if one student learns better in just the straight math, they've got that going on for them. But if they learn about what's going on in their literature or something like that, they're starting to tie it all together. So different learners can learn in different ways. But when they do learn, they've learned multiple subjects about a particular item rather than just the one. And to me, that's my observation as far as what I'm seeing, which really allows for people to have a broader view of what they're doing, as well as to accommodate the different learning styles of the different students.
I would say one thing too, as having taught this particular topic in the past and then teaching it now and seeing how things have changed, we really are requiring the students to create the mathematical model. It's not just given to them. In the past, here's a model. Find the optimum, find the vertex, and now they're actually investing the time to create the model and wrestling with, well, what are the different parts that need to come together? What do they mean? Why are they here? And sort of a sense of pride coming up with the actual model more than just going through the steps of solving it. So I think that's one big change that we've seen too. And the kids get a true sense of satisfaction from that.
If I may, in the old days, we would give the kids the mathematical model, the quadratic equation. We would say to them, manipulate the mathematical model and come up with a mathematical answer. We've now added 2 more components to this. The first component is we're starting with real-world data, and we're saying create the model. Then yes, indeed, we want you to manipulate that model and do all the traditional stuff and graph it and find the vertex and tell us, you know, what the optimal price would be. But then the other piece, the third piece, is once you've gotten your answer, you need to go back to the real world and see if it makes any sense in the context of the real world problem. So what we've added 2 more branches to the traditional approach from the past, and it makes much more sense to the kids, because now they're not just dealing with these abstract equations, they're actually creating them, which is what mathematics is all about. That's how it's used in the real world. You know, those equations aren't just out there for people to manipulate. They stand for something. They represent something. They model something from the real world. So it becomes much more important to them.
I had to say something, and that is, I hope you remember, not too long ago, James D'Amico, I believe, presented global studies to you. And I hope everybody watching at home sees a connection between global studies and what's happening in the teaching of social studies and the teaching of mathematics. And, you know, I think the science department is going to show you, they threw at kids, 2 cars had an accident. One was a Ford Taurus, one was a whatever. And they had to decide who was at fault. And they were given X amount of dollars to go out and buy whatever data they needed. And they had to prove that their insurance company didn't have to pay. So this is happening throughout the curriculum. And, you know, I just hope I make it to 2025 and I can come with my walker and see what these kids are going to be able to produce, because they're starting in kindergarten now, being bombarded, were handed ill-defined problems where instead of telling kids what they have to do, the teachers are asking kindergartners and first graders to think about what the question is in the first place. It's really very exciting stuff.
I think it's great, the pricing example that you used. It is something very tangible. Somebody can understand why a company would charge X for a product versus, you know, some other price that may have been in existence 6 months ago or whatever. Supply and demand. It's really getting people to start just thinking through things and developing that mental math capability, which is, I think, what this is all about. So it's terrific. Jim?
I wanted to go back to a question I raised. It's germane to what we heard, but it's a little maybe a narrower topic than a broader topic. A week ago on 60 Minutes, there was this
Khan Academy.
Khan Academy, and I received some communication on that, that, geez, this looks like great. They're turning their blah blah blah. And where does that fit or not in at least the concept, and how have we moved past that or
Well, the Khan Academy really does not focus on conceptual knowledge. What he does, and he does it very well, is to give these mini lessons, about 15 minutes each, and he explains a procedure. You know, exactly how to do a procedure, and he explains it very clearly and very precisely. What he does not do, that's really a 21st century skills, is make connections to the big essential questions in mathematics or go for deep understanding. He's doing what the math department is telling us that they used to do but have moved beyond. He's teaching algorithms, procedures, and explaining very clearly how to do them. But he's not going for the in-depth kind of understanding and the conceptual background. The other thing involved with that is, in a classroom situation, we, as you have seen tonight, try to get students to make their thinking visible, in part so that they can self-reflect and understand their own learning, and in part so that the teachers can make a diagnosis. If they make their thinking visible, we can understand their misconceptions and their confusion, and we can help them to get their thinking straightened out. by listening passively to the Khan Academy mini lectures, a student is not going to make his own thinking visible. He's not going to interact with the teacher. And so that deep conceptual understanding and self-reflection is not going to be there. However, having said that, we certainly don't want to pass up on the opportunity of some free material that could be helpful to us. So the way we have actually started using the Khan Academy material, and math has started with it, and some other subjects areas may do this as well when he expands into other areas, is to do what we are calling now flip the classroom. Typically, in the past, what has happened is a teacher would come into a math classroom or any other classroom and spend 15 to 20 minutes doing that mini lesson, that procedural thing that Khan does. And then there would be maybe 35 minutes left in the class for the students to do applications and true problem solving with the teacher as guide. So what some math teachers have started to do is they have gone through his little math lectures and they have identified the ones that would be appropriate. And for homework, they would tell the kids, go and look at this 15-minute segment. That's your homework. So the kids would come into class the next day, and then that 15 minutes would have been saved, and you'd have the 45 or 50-minute period for the kids to start really applying what they had learned and working on non-routine problems with the teacher's assistance and with the teacher diagnosing their thinking about those issues. So I think that we have found a place to use Khan's material within a much larger context of much deeper thinking. And of course, the other thing is it's always there. So for review, for reteaching, for going over something that you don't understand, you can call it up. The other thing I would point out, just to show you the difference, is the math program uses Hey Math. That's a platform that houses on the internet all of Westport math curriculum. Now, at first glance, it might seem like that's similar to Khan Academy, but it's not, in that it is interactive. Kids using Hey Math can get on there, they can answer questions, they can get feedback, they can move forward if they were right, and the teachers have the capacity to check on the kids and see them doing that homework. So that Hey Math platform houses our math curriculum. It is interactive and dynamic, and it's not just passive when the kids are using it. But again, when all said and done, we can use Khan Academy to be helpful to us.
Can I add something to that?
Sure.
You know, the Strategic Technology Committee is having a 5-year strategy series of sessions. There will be another one tomorrow night. And I think one of the things that we're seeing is that the tools available to teachers and to students now is just blossoming incredibly. It used to be that you had, instructor-led stuff in a classroom, and the kids would have homework, and if they wanted to study together, they'd either call each other up or they'd go over and visit. I mean, that whole model has changed so dramatically. And one of the things we're trying to figure out is how do we as the Strategic Technology Committee support these different models that would be decided by the curriculum reviews to be able to implement that kind of stuff, because it's not an easy thing, it's not an obvious thing, and the options are continuing to multiply. And that's going to be a great challenge, but I think it's going to also yield great results to our students. And to your point, how does the Khan Academy fit in? Whether we, adopt it whole hog, so to speak, or the tidbits that work for us, there are going to be certain students that I need to know how to do X, and that will be one tidbit that they will need, have their disposal.
Great for extra help.
Or just if someone learns that way. I mean, there are going to be students that like to learn that way, and this just allows that more personalization.
Jen, did you have something? Or?
I did, but I'm going to take it a different route. Are you, Michael, were you going to go? Okay. Just a quick question for the three of you who went through establishing this concept in the absence of the lens. Because, I look at the lens and it's a lot. And so I was wondering if your experience of putting together a learning concept and a learning piece like this in the absence of it, and retrospectively going back and asking peers and yourselves to put it under the lens, so to speak, if that was an interesting way to do this rather than flipping it and thinking of the lens up front and fitting your curriculum around that. Does this make any, am I making sense?
But just to kind of put things into context, we've been focusing on critical thinking for a couple of years now. So it really kind of was born under the focus on critical thinking. And I think we're all pretty good at and really keen on the whole questioning and probing. And so this really fit into that very nicely. So it wasn't exactly that we were flying blind. We kind of had the, we had the goal of critical thinking very much in our minds when we put this together. What this ended up being was affirming. And really, it was nice to see that we could put something together without having had the support and the background of the lens that really fits so nicely into what we wanted to do and what we wanted to achieve. So it ended up being affirming and enabled us to sort of take a look at it and say, yeah, now we know we're going to use this. It really helped. I'm not a 2 honors teacher. I'm an Algebra 2A teacher. And what we did was we moved the whole exercise to the end of the year to integrate it into an overall polynomial regression modeling unit. And we think it's going to be much more meaningful for those kids doing it that way. So that it was very helpful too.
Michael, you had something, and then Mike.
Sure. First of all, it was all great, and thank you. We talked last time a little bit about measuring to make sure we're sort of proving the model that seems to make sense to all of us. Do we know when the measurement will be in place?
Well, it's interesting that you asked that today because this morning we met with 2 staff members from Teachers College, and we had about an hour and a half discussion with them, particularly on the question of assessing students and then how do we measure how successful the students are being with these 21st century skills. And this is not an easy question to answer. They both told us that they are working with a new psychometrician at Teachers College, and they are really struggling with how do you measure students' success in 21st century skills. And I think the bottom line reason is most of the standardized tests we have don't measure 21st century skills. They tend to be multiple choice tests, or they're structured answers that students have to choose from, and they're right or wrong answers. They're not open-ended. They're not looking for ambiguity and complexity. So the more straightforward and multiple choice the tests are, like the CMTs and the CAPS and the SATs, et cetera, the more you can measure with validity and reliability. Now, if you're having students try to solve real-world problems where there are a variety of answers and points of view, and you're asking them to collaborate to show independent and original thinking, then there can be some debate about what the right answer is and how many points they're going to get for that answer. So basically what we learned from TC this morning was that research universities, not only across this country but across the world, are struggling with this idea of how do we measure how students are improving in their learning in terms of 21st century skills. And I wish I could tell you that they said the answer was going to be soon, but they're still struggling with that themselves. Now, I will also tell you that we did talk a little bit about a concept called cornerstone assessments, which is a big idea that we can't go into right now. But we are thinking and working with Teachers College about the concept of making cornerstone assessments that over time perhaps could show, certainly cornerstone assessments over time would show an individual student who was keeping an online portfolio if that student was getting better and deeper in their learning. Over time, with a lot of work, you could do that kind of portfolio assessment for an entire school system. but that would require, continuing to work with Teachers College. And, I'll be frank with you, one of our issues now is it costs money to work with Teachers College. And, I think we're all very concerned about what the Board of Finance is going to say and about our budget, and we've come in with a pretty lean budget. So after we talked to the TC people, we were sort of talking amongst ourselves and saying, we don't know how much work we can continue to do with them. And we sort of posited the idea of maybe trying to go to outside funding in the town. I don't know how we would do that, but money and continuing to work with Teachers College is an issue. I'm giving you kind of a long-winded answer, but I'll just give you one more piece of this. We belong to the Tri-State Consortium, as I think you all know, and that's considered the best school systems in the Tri-State area. And every year they form a study group, and Cindy and I go a couple times a semester, and we are involved in their study group. And their study question, their essential question for this year is, how do you measure student success, both individual students and across your school system, in terms of 21st century learning skills? And they're all putting their heads together and reading articles. And in fact, when Cindy and I go in May, they're asking various school systems who have started to make any progress to make, to provide case studies for us so we can all look at it. So, you're asking the right question, and hundreds of researchers across the country are asking the same question, as are we, and we will continue to wrestle with it and continue to report back to you.
I'll just say, I think we're all in agreement. Certainly, cracking that code is worth our making a high priority.
Yes.
Just a quick follow-up to that. I was curious to what degree the concept of, since collaboration is a big part of this, some of the work products will be individual ones, which are still hard to define, but then when you have a group putting something together, also figuring out the individual role and, valuing leadership and motivating others to participate versus just doing it yourself versus, who did, is that a piece of what is being looked at?
That's one of Elliot's favorite topics. Yes, go ahead.
That was a major component of our discussion this morning because, yes, we do encourage collaboration. We want kids to be able to collaborate, but we also want to be able to assess individual performance to make sure that we are constantly aware of where the strengths and weaknesses of our kids are so that we can properly address their needs and modify our instruction to meet those needs. So individual assessment is a major portion of where we're going.